Now, if we're going to use current electricity, if we're going to build a circuit so we can do something with it, we need to understand some of the different things we can put in a circuit, different electrical components. And you need to be aware not only of these components, but also the symbols that we use. So first of all, as I'm sure you all remember from primary school, this is a switch. It's basically somewhere that we can break a circuit to stop the current from flowing or join it back together. This is a cell. And a cell is just the name we give to a small unit that will push electricity around a circuit. If I join one or more cells together, then I get a battery. And all that is providing a potential difference, pushing electricity around the circuit. Now, there's our power supply. We've got a way of controlling the circuit. So all we need now are some different components so we could perhaps do something useful. And probably the first circuit you all built at primary school involved one of these, a lamp. Something that will allow us to turn electrical energy into light. You may also want to do some measurements. You might have a meter, a voltmeter to measure potential difference, or an ammeter to measure current. You might want to think about safety, especially with AC current, so you might include a fuse, something that will allow you to stop the current if it gets too big. But we also look at a whole family of components that have very, very special properties when it comes to resistance. So first of all, this is a resistor. Its only job is to stop current by a precise amount. So we design resistors to have a very specific resistance so they can control how much current gets through. This is a variable resistor. The arrow just tells me that I can change how much resistance it has. This is a thermistor. Again, it's something that can change its resistance. This is a light-dependent resistor. As the name implies, it will change its resistance depending on light. And finally, this is a diode. Now, if you remember from last time, we said Ohm's law, R equals V over I, or if I rearrange that, I can say that V equals IR, and you can see that voltage and current are in direct proportion related to resistance. So if I draw a graph for a resistor, if I draw current and voltage, then I should see a straight line through the origin, direct proportion. This tells me that a resistor always has constant resistance. It never changes. And that's really useful to us in some situations, that we can judge exactly how much current will flow through because we know that we've got a constant resistance. If I look at a different component, if I look, for example, at a lamp, a filament lamp, like a light bulb, you'll see that actually we get a different shape. And this shape will look more like this S-curve. Now, the reason for this is that as our lamp gets hot, as the current gets higher, those particles in the metal lattice get warm. Now, when these vibrating metal ions get warmer, they move more, and that means they're more likely to bump into electrons. That means the resistance goes up. So you can see here, this area of the graph has a relatively low resistance, this area has a far higher resistance. So that's our filament lamp, and its resistance changes with temperature. We can do exactly the same for a diode. Diodes are really, really useful devices. They act a little bit like an electrical valve. And all they do is, if you connect them backwards, they allow no current through at all. It's as if they've got an infinite resistance. So you'll get no current at all for a negative voltage, trying to push electricity through backwards. But as soon as you allow the voltage to push in the right direction, you'll see that this is a very good conductor. About 0.6 volts tends to be that point where suddenly a diode will allow current through. And this is a great way of making sure that electricity only flows in the direction that we want. We call these current voltage graphs, and you need to know these three shapes for those three components. Diode only allows forwards current. Now, there are three other components here that we said can change their resistance. And these are really useful to know about. A variable resistance changes if you change it. If you've ever turned a dial on a dimmer switch to put the lights on brighter, or turned up a volume control, that's using a variable resistor. Its resistance changes because of humans. This is a thermistor. Its resistance changes because of temperature. If it gets hot, its resistance goes down, which is really useful if you want to set a thermostat to switch the heating on if you get too cold. And this LDR, this light-dependent resistor, it changes its resistance with light. So the brighter the light, the lower the resistance. Again, you could use that to set up a circuit that would automatically turn lights on if it got too dark.